Everybody, we want to thank you in advance for coming to our session today. Radu and I are going to be talking about Brigade. So Brigade is event-driven scripting for Kubernetes. And who are we? We're both software engineers at Microsoft in a group that identifies outwardly as Deus Labs. We're both open source maintainers for Brigade and a few other projects. As for myself, my info is down at the bottom there. You can find me on Twitter at Rancourt. And I'm a dad, a martial arts instructor, and a comic book nerd. And I'll let Radu introduce himself.
Hello, everyone. I'm Radu. You can find me on the internet if you need to contact me. I blog quite a bit about open source and distributed systems and WebAssembly and things like that. I'm trying to learn to play the piano. I'm a cyclist and aspiring trail runner and a WebAssembly tinker. Back to Kent.
All right, thanks, Radu. So to talk about Brigade, we're going to give a little bit of historical background about where the project comes from because it's kind of interesting. So in fall of 2016, Deus, and this is before Deus was later acquired by Microsoft, we were doing something that we called the Shark Tank exercise, which was kind of modeled after the television program Shark Tank. And so engineers broke into groups and pitched new ideas to management. And the idea was that the winning pitch, spoiler alert, Brigade won that year, and Helm won the previous year. And the pitch began with the comparison of Kubernetes to an operating system. And this is kind of also how the pitch for Helm began also. Both years, the winning teams who came up with these ideas asked the question: if you think of Kubernetes like an operating system of sorts, what pieces of functionality that we're accustomed to in a real operating system are missing from Kubernetes? So just to dive into this analogy a little bit, what is an operating system? And this is kind of like the Wikipedia level definition here, but it's a program that, after being initially loaded into the computer, manages all the other programs. So Kubernetes can be thought of as your cluster operating system. If an OS manages processes on a machine and Kubernetes manages containers in a cluster, Kubernetes is an operating system of sorts. So when Helm was conceived, the thing that was obviously missing from Kubernetes at the time was a package manager. And when Brigade was conceived, the thing that was conspicuously missing was some kind of shell scripting. So in traditional shell scripting on your desktop operating system, it's flow control that wraps the execution of processes, but it's not opinionated about what those processes do or how they run. So what would shell scripting in a cluster look like? Well, it would be flow control that wraps the execution of containers, but isn't particularly opinionated about what the containers do. So that's what led pretty directly to Brigade. Fast forward to the current day, and we're a cloud-native sandbox project. We are event-driven scripting for Kubernetes. We're extremely lightweight and Kubernetes native. And Brigade chains together containers to create workflows. And Radu will show us more about that as we get going. Some key design decisions that went into creating Brigade. What programming language to use? If you're going to create some kind of scripting engine, what language do you write those scripts in? How can data be shared between containers? If you think about writing a traditional shell scripts, like in your desktop operating system, you have several ways that data can can go into a process or come out of a process. So you can pass commands on the command line, or you can use a file as input, or you can pipe some input in from standard in. Same thing on the tail end, getting output out of a process. You could be writing to a file, or you could be writing something to standard out, and you could pipe that into another process. When should scripts be executed? It's pretty simple in a desktop operating system. A script is executed when you type its name and hit enter. But what are the triggers for executing a script in a cloud environment? So that's another thing that had to be considered. So on the subject of what language to use, these stats that you're looking at here are a little bit out of date, but I think that's okay. I think it's relevant to show kind of point in time statistics here. So it was 2016 when this decision was being made, and JavaScript was then, as is now, overwhelmingly one of the most popular programming languages, the most popular programming language. And why JavaScript? So yes, popular, we've established that. Rich ecosystem of tools, and extremely flexible. Just to back up that second bullet point about the rich ecosystem of tools, again, this is a couple of years ago. NPM, which is the one of the package managers for JavaScript, they surpassed 1 billion weekly package pulls. So if that doesn't speak to how vibrant the ecosystem is, and how many tools are available and how popular they are, I don't know what does. So JavaScript, basically slam dunk here. So sharing data between containers, we talked about that. We know what sharing data between processes looks like on your desktop operating system. What does it look like in the cloud? So passing information to a container, well, it's not that different than passing information to a process on your desktop. You can pass things in through the commands. So command line flags or command arguments, right? You do specify a command or arguments when you create a container. So that's one way of getting information into the container. You have environment variables, of course, and you can pass information to a process in a container using a file. How do you get information out of containers? Well, you have standard out. You have exit codes. What was the exit code of the containerized process? And of course, you have files. So in the end, everything is just JavaScript. So I will quickly go through this one little snippet. I'll let Radu go into much more detail when he does his demos. But what we have here is we're basically importing the Brigade library. Brigade is just a library for JavaScript that exposes the primitives that you need for creating these pipelines. So they have primitives like jobs, for instance, and we see that in use here. So we say var program equals new job. We give it a name, and we tell it what Docker container to base this job on. And we give it some tasks to do: echo hello, echo goodbye. These will be executed in order. We set an environment variable. We give the variable key the value, and then we say program.run. So this is a pretty simple script that just runs one container. So there's still the question of when to execute. As I said, if you were talking about a desktop operating system, things execute when you type the script's name and hit enter, but that's not really the way you're going to expect things to work in the cloud, right? So as I understand it, some inspiration for this came actually from AppleScript, which is a little bit more event-driven in terms of you do something on your Mac desktop and that triggers some script. So that's how Brigade works. We are event-driven, and gateways broker events from upstream systems like GitHub or Docker Hub or Slack, and there are others. We have other integrations as well, and you can pretty easily build your own. And event handlers therefore become the entry points into your Brigade scripts. So so this is roughly what that looks like. You have over on the left, you have some kind of upstream event. So this could be like a webhook coming from GitHub or Slack or something like that. And it comes into a gateway, which is a little program that understands the events from the upstream system and turns them into events that it emits into Brigade, which triggers a build. So this is the same script we looked at before, but adapted a little bit to look event-driven. So you can see we're still importing some things from Brigadier. Before we just imported job. This time we are importing events as well. And you can see on the next line we're saying events.on some event. Then we want this container to execute. And these lines that you see here are the same lines that we looked at earlier. So some popular use cases that we know Brigade has been used to tackle. CI/CD is probably the most popular, although I really want to note that Brigade is not a CI/CD platform. It's just that it's one popular use for it. We know of teams that have done nightly security audits of their source code repositories. You can use it for things like aggregating and analyzing data to build reports. You could create complex sandbox environments on demand. So you could have some event that might trigger a kind cluster being deployed within your Kubernetes cluster in order to facilitate end-to-end testing of something that you do. So at this point, I'm going to turn it over to Radu to do a little demo, and then we'll come back to me at the end to get some updates about the future of the project.
Hello everyone. In this video, we will get started with Brigade. First of all, you will need a Kubernetes cluster. You can use any cloud-provided cluster or a local one. In this case, I'm using Docker Desktop with a single node cluster. Everything you're about to see can be found on the documentation website for Brigade. And to get started, we will deploy Brigade in our cluster using Helm. I'm using Helm 3 to deploy Brigade to its own namespace. And at this point, we can start using the Brigade CLI, which can be downloaded from the release page on GitHub, and run brig check, which makes sure that all of Brigade's components are properly deployed in our cluster and are running. So we can see an API server, a controller, which is listening for events, and an optional web dashboard. And now we are ready to start writing Brigade scripts. What I did previously, I created a Brigade project, which is just a logical grouping for data secrets and things like that. So I didn't have to create it right now. It's called Hello KubeCon, and we will reference it when generating events through the Brig CLI. So the simplest Brigade script requires us to import Brigadier, which is the JavaScript API for Brigade. Specifically, we're using the events and job objects, which we will see throughout the examples in this video. Brigade is an event-driven scripting engine on top of Kubernetes. So every entry point in a Brigade script is an event handler. In this case, we're reacting to an event called exec, and we're reacting by executing this particular function. So what this function does is every time there's an exec event, we create a new job called do nothing based on an Alpine container, and we execute the following two jobs, echo hello and echo world, and then we run it. And we can use brig to generate an exec event, which the script and the controller are listening for. and we're passing the name of the project that we saw earlier and the name of the script file that we want to execute. If this was a real-world scenario, the Brigade.js file would be somewhere in a GitHub repo, and the event itself would be generated by an external system. And right now, the Brigade worker executed our script, and we can start inspecting what happened in our cluster. Brigade offers multiple ways of seeing what's happening in a cluster. First of all, we have a web dashboard that I mentioned earlier. And Brig dashboard is a CLI command that tunnels traffic from your machine to inside a cluster using port forwarding. And you can see the name of the project. There was an event from the Brigade CLI called exec that ran a few seconds ago. And there's a job called do nothing, and if we click on it, we see the logs for our jobs. If you're not familiar with it or don't have access to a web dashboard or browser in your environment, you can also use a CLI dashboard built by the community. There's a Brig term command that starts this dashboard, and you can see the same sorts of information, but in a terminal dashboard. As well, you can see the logs, type of job, source, and everything else. Of course, you can create multiple job objects and run them in the same way. But Brigade also offers you a way of grouping multiple jobs. So imagine if you have lots and lots of jobs and you want to schedule and orchestrate their execution. Brigade offers an API called groups, and one of the methods on the group object is run each, which makes sure that your jobs are run sequentially. So hello is started, its execution is finished, and then goodbye is started. So if we executed this this Brigade script, we would expect that hello to start and finish, and then goodbye to be executed. And Brig term also offers a very nice visual representation of the pipeline invocation and execution. And here we can see Brigade started, and then after it finished, the goodbye job was started. So, and the logs as well. Because this is plain JavaScript, you also have multiple ways of making sure you can await certain operations. The run function returns a JavaScript native promise. So if you're familiar with the async await functionality in JavaScript, you can also use that as well. If you're not, if you're more familiar with grouping API, you can just use that. Brigade also offers a very simple way of dealing with storage in Kubernetes. There's an object called storage that you can enable or disable per job. And if you enable storage for jobs in your event execution, the Brigade worker will create a persistent volume and attach it to each of these jobs that require it. So if we run this, what we expect to happen is the persistent volume will be mounted on Mount Brigade share by default. You can change that, of course. The first job will write, the first two jobs will write in the file, and the third job will print the content of the file. So if we go to Brigade term, and the first one wrote into the file, the second one wrote as well, and the third job printed the contents of the particular file. Again, what this does is it creates persistent volume storages, it attaches them to each of the jobs sequentially, and then deletes them at the end of the execution. Keep in mind that the storage is volatile, so it's deleted at the end of the execution. But it's a very simple way of attaching storage to event executions. There's also another type of storage that Brigade surfaces in its API called a cache. The build storage is storage per event. So on every new exec event, Brigade will create a new persistent volume and it will attach it to each of these jobs. In the case of a cache, it's the persistent volume survives multiple invocations of the same event type. So every time there's a new exec event and then you cache your job, it's by the name of the job and container. The same persistent volume will be attached. And you can use that to, for example, build caches, compiler caches, and things like that. So if we execute this particular script multiple times, we expect the same persistent volume to be attached to this job and us to be able to write across multiple event executions. So we can see if we run it again, it will append to that particular file and the same storage will be attached again. So we can see it was attached again. Another type of interesting thing we can do with Brigade is get results out of job executions. Particularly, standard output is one of the things we can get out of event executions. And here you can see another way of waiting for jobs. You can use the thenable syntax in JavaScript. Is the same sort of result as you would get with awaiting job runs, but specifically we start a new job called 1, we wait for it to finish, we grab its result, which is the standard output, and use it as input for job number 2, and use it to echo whatever the input was. So if we execute this, what we would expect to happen is job 1 to start and finish, its standard output captured by Brigade and used as input for job number 2. And if we look at this, we can see job 1 started, it finished, and then job 2 exited, and we can see the output for the first one used as input for the second one, which is rather difficult to do if you don't have a way of capturing output with a real programming language. The final thing I want to show you with a real programming language is handling errors and ways to handle cleanup, for example, if something goes wrong. We have a first job that will exit successfully, and the second one which exits with an error code every time. What we want to do is make sure that we catch any sort of exceptions in the execution and make sure to clean up, do some other operations if it fails. So if we execute this, we expect the second job to fail, but only the job. The execution of the script itself will continue, and we can continue to execute code that does, for example, cleanup. And as expected, it failed to run to completion, but the second job failed. But if we have a look at the logs for the worker itself, we can see that the execution continued, and we could have done other things as well. This is just these are a few things that you can do with Brigade. For a complete guide, I recommend you check out the Brigade documentation. Everything you've seen here is detailed and described here, together with many more examples. Thanks. Enjoy your conference.
Okay, so just to recap a few quick things from Radu's demo. The slide is for your reference if you want to get started quickly. Just add the Helm repository for Brigade. We're using Helm 3 here on this slide. Create a namespace for it and install it. Then run Brigade check to make sure that everything is up and running. Okay, so we'll talk quickly about community and integrations. We have built-in support for CloudEvents, integrations for, that first bullet point shouldn't be there, CloudEvents, as I've mentioned already. GitHub checks API. integrations for Prometheus, virtual kubelets, and others, and also arbitrary event data that can be ingested via generic. We have a growing ecosystem, so we have Kashti. You saw that in Radu's demo. Kashti is a web-based dashboard for looking at your Brigade pipelines. Brigade Term, which Radu also showed, started as a community project and then actually got folded into the CLI itself. And there are several gateways listed here. We have gateways for Bitbucket, GitLab. We talk about a lot of things. And of course, we love developers. Brigade is for developers. This isn't for end users. So we want you to get involved. So ways of doing that, there's docs.brigade.sh, which Radu showed you a little preview of. And some other ways to get involved. You can find us on GitHub or on the Kubernetes Slack. We have our own channel there. And we also have a bi-weekly community meeting that we haven't been doing for a while. We're going to be getting it started again very shortly, so stay tuned for that. Now it's time to talk about Brigade 2.0 and the future of the project. So Brigade 2.0 is going to usher in sort of a nuanced shift from Brigade as an event-driven scripting for Kubernetes platform to one that is event-driven scripting for Kubernetes. So note the parentheses there. So Kubernetes fades into the background and becomes a little bit more of an implementation detail. Although we're not planning on supporting anything other than Kubernetes, but we want Kubernetes to be a little bit less in your face, as it were, because we want to make Brigade useful to developers who don't necessarily have Kubernetes expertise. If you were paying close attention to Radu's demos, none of the scripts that he showed really had anything that was especially Kubernetes specific within them. So we think there's a lot of potential here for the power of Brigade to be leveraged by people who aren't necessarily Kubernetes experts. We're going to be building for the enterprise. We're going to be doing some things that we haven't done previously up until this point. We've been super lightweight up until this point. We're going to be getting, I don't want to say heavier, but we're going to be getting a little bit more robust. So we're going to be persisting project and event data outside of Kubernetes in a document store. And we're going to be persisting log data outside of Kubernetes, the logs from your jobs, that is. And utilizing a message bus to do things like limit concurrent work, both globally and on a per project basis, and to do some fair scheduling and things like that. And we hope that this paves the way for an expanded ecosystem. So we'll be introducing a new API, bindings to that API for Go, and improved support for alternative worker images. So everything that you've seen demoed here today uses JavaScript to define pipelines, but lots of people have asked about using YAML or TypeScript or something else to define their pipelines. And actually, the previous KubeCon, we showed a demo of that being done. So once we have better support for these alternative workers into Brigade 2.0, you can probably look for official support for declarative pipelines to follow with subsequent release. Okay, and the proposal for Brigade 2.0 was, as we're recording this, either recently ratified or about to be ratified, in which case development will be starting. So probably by the time you see this video, it's underway. We are targeting an alpha release by the end of the year and hoping to be GA in the middle of 2021. And And with that, we'll open it up to questions and answers.
Okay. Good morning.
Hello.
Hello. I'm not centered in my... All right. Any questions from anybody? Okay. We have a question from Bridget. And let me see if... Here, I'm publishing the question. I believe everybody can see it now, but I'll answer it here. She asks, on the 2.0 proposal, do we see this as being Brigade's final form, or will it change further? I see it as well. It's hard to answer because I can't tell the future, but I see it as being much closer to where we want to be long term. The main thing about Brigade 2.0 is that it makes Kubernetes more of an implementation detail than it is today. So I believe that, in the unlikely event, and I mean really unlikely event, that, Kubernetes becomes obsolete or fades into obscurity or something like that, you might see someday a Brigade 3.0 that introduces support for some kind of alternative orchestrator or something like that. But at the moment, I see 2.0 as getting us as close to where we know we want to be as we are aware. If that answers the question. Okay, and Jonathan asks, how does Brigade scale in terms of the amount of data possible to pass between jobs and workers? I'll let Radu jump in here if he thinks that I misspeak at all. But some of the different ways that are available to you of sharing jobs between sharing data between jobs would include using the file system. So you can have a read-write many volume, such as an NFS volume or something like that, attached to all of your jobs. And so they can actually share a file system. So I guess the question in terms of limits is, how big of a file can you write? And I'll let Radu correct me if he thinks that's wrong.
Yeah, I think you're right. In both cases, essentially you can pass data either as standard input or arguments for the job you're about to start, or write the data in a volume that you can share between jobs. Either way, there's no technical limit that either Brigade or Linux imposes on the file size. That being said, we've usually guided people towards using standard input if they have very quick output from one container to the other, and they can use standard input for that, and use actual Kubernetes volumes for something more robust, where you want to pass multiple files or larger amounts of data. That being said, both of them should work as well. There's another question. Does running the script have the possibility of accessing the shared storage? So whenever running the script will actually orchestrate starting the jobs and attaching the volumes. So technically, you do have access to it, but it's not exposed in the API that you're using. So if you need to access shared storage, the recommended way of doing that is by starting a job and accessing the storage there. I would be curious to understand the use case for accessing the shared storage from Brigade.js itself.
Yeah, can I comment on this as well, Radu? So yeah, as things stand currently, the shared storage is created by the worker. So the worker is the thing that's executing your Brigade.js. So during the execution of the script, the shared storage gets created and then control gets passed to your script. Because the shared storage is created by the worker, it's too late to mount that volume into the worker. So your script does not currently have direct access to that volume. But this isn't the first time we've heard this question. People have asked about this before. And while I might not be entirely clear about the use case, it's been requested often enough that I foresee this changing in Brigade 2.0, especially because as we're trying to add better support for alternative workers, we want to lower the bar for what it takes to implement a custom worker, which means offloading as much responsibility to kind of the Brigade core as possible. So definitely I foresee this changing in Brigade 2.0, where by the time a worker launches, the shared volume has already been created and can be mounted into the worker itself if it needs to be accessed. So I do foresee that changing, and I hope that answers your question.
And backing up on my question a little bit, while the workflow Ken described is accurate for default shared storage in Brigade, there's nothing stopping you from importing the Kubernetes JavaScript client library in Brigade.js and creating a volume there and then manually mounting it. So you have that option. And I think the document on the docs.brigade.sh, we have a few examples of actually importing the Kubernetes JavaScript client and creating namespaces and things like that. So you definitely have that option there, although it's not necessarily straightforward.
Okay, and I think that's it for questions, I guess. So we're going to wrap up, and thank you all for coming to our talk.
Thank you. Enjoy the rest of your conference.